Section 8 is samples and surveys. So we're talking about surveys and studies and experiments and samples, and there's a lot of vocabulary here. So make sure you're writing all these down, paying attention. We've kind of said a few of these words as the chapter has gone on, but here they are again. Population is all the members of a set. So the population of the school would be all the members or all the students that are in this school. A sample is a part of the population. So if you're taking a sample, you're not looking at the entire population. You're just selecting a sample of people, not everybody in the population. If you took everybody in the population, then it would just be the population, not a sample. So then we have 4 different types of samples that we can take: convenience sample, self-selected sample, systematic sample, and random sample. A convenience sample, if you think of the word convenience like convenience store, you kind of know what a convenient thing is. So a convenience sample, you just select any members of a population who are conveniently or readily available. Like if I wanted to take a sample of the school and find out what their favorite movie was, I could just ask all of you guys, since you're conveniently sitting right here. That's a convenient sample. A self-selected sample is a sample where only members of a population who volunteer for the sample are used. So you don't have to be a part of the survey or not, but if you turn in the survey, then you are basically part of the self-selected sample. You guys chose to do it, so therefore that's a self-selected sample. A systematic sample orders the population in some way and then selects people at random intervals from that list. It's a systematic sample. There was some sort of order to the way that things were taken. A random sample is all of the members of a population are equally likely to be selected for the sample. So that's like where you're drawing names out of a hat or something. That's a random sample. Samples vary in how well they represent a population. A sample can have bias. Hopefully you've heard that word before. Bias can be introduced when part of a population is either over or underrepresented. So like if I want to find out what your favorite movie is and I just ask a bunch of boys what their favorite movie is that maybe going to introduce bias into the sample? No? Yeah, because boys probably aren't going to say, you know, their favorite movie is Hope Floats or something, some romance movie. They're probably going to say something like Fast and Furious 7, right? So in that case, the male population was overrepresented and the female population was underrepresented for that survey. So that's where bias comes into play. Bias is a systematic error introduced by a sampling method. The way that I selected these people introduced bias. Okay, so we have 3 different scenarios here for a different type of sampling method, and a little setup. The newspaper wants to find out what percent of Graybill's population favors a property tax increase to raise money for a new swimming pool, because we need one, apparently. What is the sampling method for each situation? And then, does the sample have a bias? And then, if it does, explain why or why not. So for the first one, a newspaper article on the tax increase invites readers to express their opinions on the newspaper's website. What type of sampling method would that be? So what would that be called? Self-selected sample. That's right. Because people who do this are taking their own time and their own energy, and they're taking part in this on their own. So it's self-selected. There's no bias there? Anybody can do it, that's right. But who is likely to do it?
People who don't have access to the internet can't do it.
Okay, good. It's an online thing. So if you don't have access to the internet, you can't do it. So would there be bias then? Okay. What about just the people in general? Somebody was talking about they could be swimmers that did it. What if all the swimmers wrote in and stated their opinion? Would there be bias then?
No.
What are we going to hear about from the swimmers? They want a pool, right? What about other people who are generally upset about the fact that they'd be getting a property tax increase? What if they wrote in? What are they going to say? Yeah, they don't want to pay for stuff they're not going to use. They don't want to spend more money on something they're not interested in. So is there going to be bias here? Yeah, I'm going to say potential. There's potential bias just because of the people who could submit their articles or their opinions to the newspaper online. A reporter interviews people who used to use the old pool before they tore it down. What type of sampling method is that? It's definitely not self-selected. Okay, it's not systematic because they didn't do some sort of ordered list. It's a convenience sample, yeah. This reporter specifically went out and looked for people who were former users of the pool. Maybe there was a former users of the pool party in the parking lot that used to have the pool in it, and the reporter went and interviewed people there. That would definitely be a convenience sample. Now, is there bias here? Yes, why? Yeah, they're only getting one side of the story. And everybody who used to use the pool is probably going to say, raise the taxes. So there's definitely bias on this. A survey service calls every 50th listing in the phone book for Grable. That's what systematic looks like. Systematic has an ordered list, or people are put in order, or things are put in order. The phone book is in order alphabetically. And then if you just go through the phone book and call every 50th person, you wind up with a systematic sample. And is there going to be bias there? Possibly, but in general, this is more like a random sample that you're picking. So in general, no, there should be no bias. You could randomly have the 10 people that you call be people who really oppose the pool. And then, yeah, there'd be bias, but in general, there should not be bias on this. Okay, so then we have different study methods for our samples. One way to collect sample information is to perform a study. So we have three types to choose from. We have an observational study, we have a controlled experiment, and we have a survey. I've told you stories about my unfriend Paul, who likes to have experiments done on him for money. We did a survey as a class. We went around and asked students to pick a number from 1 to 10. An observational study is where things are observed only. Observational studies happen in school all the time. You guys just usually aren't aware of it because you're the subjects of it. There's one going on in the back of the room right now, actually. An observational study where things are observed only. No attempt is ever made to influence any outcome. Anybody ever watch a nature show where you see like there's a film crew that's following a beaver around or something like that for a couple years? The film crew is doing an observational study. They are not influencing the outcome of nature in any way. Even if their goal was to follow this beaver around for 2 years, and a year into it, that beaver starts starving in the middle of winter and goes out of his home and starts foraging around for food and then is about to get attacked by some other hungry animal so that it can have its food. The film crew cannot influence the outcome of that situation. They would have to let the beaver die. So that's what an observational study is. You don't do anything, you just sit there and watch. You're a fly on the wall. A controlled experiment is something that is intentionally done to a group or population, and then their response is observed. So for a controlled experiment, you volunteer to go to the major pharmaceutical company and have yourself injected with 3 different types of drugs, and then they're going to watch what happens. And then it turns out that half your face goes numb, you drool, and then start convulsing. That would be a controlled experiment. Then you go to the hospital. The sample gets divided into 2 groups, and we've talked about how they divide up groups. There's always a control group and an experimental group. So up here it's called the treatment group. Let's also call that experimental. You'll see that written both ways, either control and treatment or control and experimental. Either way, experimental or treatment group, the group that has something done to it. So they're actually getting shot up with whatever drug it was. The control group, nothing is done to the control group, but they receive the same sort of exposure as the other group received, though there is no drug involved. So they're given a placebo. Or if it was an injection, they'd be given basically just like a saline solution injection, so that they thought that they might have received the drug as well. But nothing is done to that group. The results from both groups are then compared. Like I said, we've talked about that. We did that when we were looking at conditional probability tables. The last study type is a survey. Every member of a sample is asked a set of questions, and then from there you basically compile your data, and then you look at the results. A poorly designed study will result in unreliable statistics. So even a survey question, if the question is worded poorly, your results may not be reliable. Always analyze the study's methods before making general conclusions about a population. If the study had faulty methods, then the conclusions that you make will be all wrong, potentially. All right, we have a couple examples here to look at. Which type of study method is described in each situation? That's part A. Then part B, should the sample statistics be used to make a general conclusion about the population? So let's take a look at the first one. Researchers randomly choose 2 groups from 10 volunteers. Over a period of 8 weeks, one group eats ice cream before going to sleep every night, and the other does not. Volunteers were monitoring devices while sleeping, and researchers record dream activity. So what would this be? Is this an experimental study? Is it a survey? Is it an observational study? Why is it experimental? So something is being done to something, okay? Is there a control group and an experimental group? Yep. The group that eats ice cream is the experimental group. The other group does not eat ice cream. They're the control group. They're both taking part in a sleep study, though, basically. So this is an experimental study. Okay, what type of study method? Experimental study. Should the sample statistics be used to make a general conclusion about the population? What would the population here be? The 10 volunteers are the sample. That's the sample. What's the population?
20 people.
There's only 10 people. And that's the sample. So what's the population?
Any living human being that has a dream.
Everybody who sleeps, which is everybody. That's right. So the population is everybody. So we have a group of 10 people. They're divided into 2 groups. Is that going to be good enough to make a general conclusion about the population of the world? No? Why not? Yeah, 5 people per group is nowhere near enough. We need more data. More people. Way more people need to be included in that study, and not just 5. Chances are with 5 people, you're probably not even really getting a good sample of males versus females, or young versus old. There's lots of different variables going on there. How about the second one? Students in a science class record the height of bean plants as they grow. That is an observational study. Good.
It depends on how they're doing it. The way that we did it is watered one, you watered one every other day, and 2 watered.
Okay, now in that case where you water one a certain way and you water another a different way, what is that? That's an experimental study. You have one group that's being treated one way and another group that's being treated another way. This is just you recording the height of a bean plant as it grows. All you're doing is watching it grow. Okay? That's an observational study. So should the statistics be used to make a general conclusion about the population of what? What's the population here? All bean plants. No. Why not? Well, it says bean plants. We don't know how many there are. There's lots of different types of bean plants, but what else? Different weather, different climates at different places, yeah. Or the fact that maybe this is a science class and so you're doing this in a inside where the temperature of the room is controlled, and like you brought up the watering thing, maybe we're watering at a regular interval and things like that. So there's a lot going on here that means that we should probably not make a general conclusion about the population of beans. How about student council members ask every 10th student in the lunch line if they like the cafeteria food? This is a survey. Is this going to give us a general conclusion about the population? So we are asking, the student council is asking every 10th student in lunch line if they like the cafeteria food. Is this going to give us a good analysis of the entire school? Why not? Good, we have an open campus here. A lot of people go to Ron's or they go over to Maverick or whatever for lunch, or they go home. So not everybody eats lunch.
But are we talking about eat lunch, or are we talking about the whole student body?
If I'm surveying the kids in line for the cafeteria food, these are the people who are not going home, they're not going to Ron's, they're not going to Maverick, they're actually standing in line for cafeteria food. Now on top of that, how many people are standing in line for cafeteria food? There's like 200 people in this school.
I'm saying 20.
Probably more like 30. So if you ask every 10th student in lunch line, how many kids are you getting? 3, maybe 4? Is that going to be a good representation of the 200 people in this school? No, it's not. So that's another reason there that you would have to write, okay? So that's the type of thing that goes on in this section. You think of the type of methods being used. You talk about what type of study we're dealing with, what type of the first group of stuff that we did, and then also whether or not there's bias or whether or not the study itself is going to give you good results. When you design a survey, so specifically a survey where you go out and ask a population something, whether it's systematic or not, care must be taken to not introduce bias, even if it is unintentional bias. Even just the way you word stuff can introduce bias, or some things that you show people can introduce bias. Even the way that you're dressed, if you're going out door to door, can introduce bias. In addition, your survey needs to avoid using words or other clues that might lead people to respond in a certain way. So here's the setup right here. Don't say anything. Let's just read it. Develop a sampling method for the following situation. We want to make a survey, basically. Here's the situation. During the 2008 Olympic Games, a U.S. swimmer won more medals than any other swimmer in history. What sampling method could you use to find the percent of students in your school who recognize that swimmer from a photograph? What is an example of a survey question that is likely to yield information that has no bias? Say nothing. Who is this swimmer? Michael Phelps. Did you know that just by reading the information? Okay. So, obviously we know who it is. We read the paragraph. But you are going to go out into the hallway or something and know. And you're going to ask people if they know who this is. So, what sampling method could you use to find the percent of students in your school who recognize that swimmer from a photograph? But we want to do this without introducing any bias. So we're going to have to go out and hold up a photograph and also ask a question. And there has to be zero bias. What can we do? Sure, say what the question might be. Do you know who this is? Does that have any bias in it at all?
No.
Did he say, do you know who this swimmer is? Did he say, do you know who this Olympian is? Did he even say, do you know who this man is? No, there was no bias in that whatsoever. So the question is a good question. It needs to say, do you know who this is? You're not even asking who it is. You're just saying, do you know who this is? So they could even just say yes or no on that question. That's right. So you can't choose a picture of him in a Speedo, right? You can't choose a picture of him without medals. A blank background, no American flag, no Olympic uniform, not a shaved head, no goggles.
Well, if it's shaved head, it's going to be this much.
Unless he has a normally shaved head. Actually, he doesn't. He doesn't even shave his head. He wears a cap. But no cap, right? None of the normal equipment that he normally would be seen using on TV when people are watching him swim. No picture of a pool in the background. Basically just him standing there looking goofy. Okay? That is how you would that's how you would have to do that survey so that you do not introduce bias. So the homework involves all of this vocabulary basically, where you're stating what type of survey or sampling method it is that you're working with, and also whether or not there's bias, and even how to not introduce bias. So all of these things need to be thought about as you're doing the homework.